Right now, we are seeing an absolute explosion of IoT devices and AI processing happening right at the edge of our networks. It's literally everywhere. And because of that, mastering the infrastructure behind it is more critical than ever. So, welcome to this explainer. Today, we're going to dive right into a really fascinating blueprint for mastering edge storage systems. We're looking at a highly specialized curriculum, one designed to take a learner from the absolute basics all the way to complex, real-world deployment. If you've ever wondered how professionals actually train to build and manage the localized data centers of the future, well, you are in the exact right place.
So, what does it actually take to master edge computing? That is our ultimate challenge today as we deconstruct the exact curriculum required to build the next generation of internet infrastructure. And spoiler alert, it takes significantly more than just knowing what a server is. Think of building edge infrastructure kind of like building a decentralized nervous system for an entire smart city. It requires a highly structured, step-by-step educational journey to get those localized reflexes perfectly timed. Today, we're going to look under the hood of this specific syllabus to see exactly how a learner synthesizes requirements, designs alternative solutions, and ultimately proves their competence out in the field.
Okay, here's our roadmap for this explainer. We'll kick things off with the edge storage curriculum, then move inside edge data centers, explore lightweight clouds and services, tackle orchestrating 5G network slices, and finally, design the final solution. Let's jump right into Section 1, the Edge Storage Curriculum. Analyzing requirements. Before a learner can build anything, I mean literally anything, we have to understand the foundational goal of this entire syllabus and how those requirements are analyzed. The absolutely crucial point here is that every single topic we cover serves one overarching learning objective, making the learner analyze different storage requirements for edge computing. This isn't just about memorizing definitions from a textbook. It's a highly active, analytical process. Think about it for a second. Analyzing requirements at the edge is wildly different from dealing with centralized cloud storage. You're dealing with severe constraints, power limitations, tiny physical spaces, and ultra-low latency demands. Everything revolves around understanding exactly what those localized edge environments demand when it comes to storing data safely and, most importantly, quickly. And this is the journey taking us from theory all the way down to practical application. We start out with the introduction to edge data centers, progress right into lightweight edge clouds and their services, navigate the incredibly complex management and orchestration of 5G slices, and then we cap it all off with a hands-on demonstration using open source tools. What does it actually feel like for a learner to move from the abstract theory of a data center to getting their hands dirty with code? Well, this structure ensures a learner doesn't just read about edge storage, they get to see it in action and build real-world competence. Moving right along to Section 2, Inside Edge Data Centers, the core of edge computing. Here is where we unlock the first set of core competencies focused entirely on the physical and conceptual data center itself. Before we build, Learning Outcome 3.3 requires us to firmly identify the role of the edge data center in the broader landscape of edge computing. You simply can't design a solution if you don't know where your infrastructure sits within the wider network, right? What does identifying this role actually mean in practice? Well, you have to ask, is this specific data center acting as a localized cache for a massive streaming service? Or maybe it's a rapid processing hub for an autonomous vehicle network. You absolutely have to know its specific, human-impacting role before you can even think about properly provisioning it. Now, take a look at the deliberate progression of action verbs mapped out here. You don't just jump into building. First, you're required to synthesize the scattered requirements for the edge data center. Then, as we just mentioned, you must identify the specific role of your infrastructure. Only then are you allowed to apply those edge-based concepts to analyze the requirements. These performance indicators you see attached to the outcomes, they act as checkpoints. They ensure the learner hits every single one of these evolutionary steps, transforming from just a passive observer into someone who can actively engineer a solution based on synthesized data. All right, Section 3, lightweight clouds and services, nimble storage at the edge. Having mastered the physical requirements, we transition to the software and services layer. So why do we need lightweight clouds? Well, at the edge of a network, you usually don't have the massive computing horsepower of a centralized hub. This learning outcome, LO 3.2, challenges us to literally design different lightweight alternative edge cloud services. And crucially, the syllabus notes that these services are provided by different service providers. This is a massive challenge in the real world. You aren't just dealing with one seamless, monolithic ecosystem. You're often patching together localized, lightweight services from a really diverse multi-vendor landscape. This learning outcome tests if you can engineer harmony out of all that potential chaos. And Performance Indicator 3.2.1? Yeah, that isn't just a gentle suggestion, it is a laser-focused metric used to measure your success in designing those lightweight storage alternatives. The grading here is incredibly strict. If your design isn't nimble enough, or if it buckles under the severe constraints of an edge environment, this indicator will catch it immediately. It ensures the learner has thoroughly grasped the design principles for resilient, edge-based cloud services before they're allowed to move on.
Which brings us to Section 4, orchestrating 5G network slices, managing the connectivity. But think about this. What happens if we successfully build these edge centers and deploy these lightweight clouds, but we completely fail to orchestrate our connectivity properly across them? That is exactly where the curriculum brings in the cutting-edge connectivity of 5G. The syllabus outlines two key goals here. First, Learning Outcome 3.4, where we must identify the orchestration of network slices across three different domains: 5G, the edge, and the cloud. If you aren't familiar, just think of network slices like dedicated VIP lanes on a digital highway, guaranteeing speed for critical applications. Then it steps up a notch with LO 3.6, requiring the learner to actively apply edge-based data center concepts to the actual management and orchestration of those VIP lanes. This is where the training wheels officially come off. The curriculum demands a massive jump from theory to practice right here. You evolve from merely identifying how orchestration works in a safe classroom setting to actually picking up the digital wrench and applying edge-based concepts to manage those network slices yourself. It beautifully illustrates how the learner is continuously pushed out of their comfort zone, transitioning from observation into active, high-stakes management. And finally, Section 5, designing the final solution, the boss level. Welcome to the boss level of this explainer. This is where all your synthesized requirements and applied concepts are put to the ultimate test in designing the final solution. Let's see how this builds into an actionable roadmap. It moves step by step. Step 1 brings back LO 3.5, applying concepts to analyze the requirements. Then in Step 2, under LO 3.7, you must design and analyze an edge storage solution to meet functional requirements. And actually, this is the really key part. Select the most appropriate proposal. You aren't just designing in a vacuum here. You must analyze competing proposals and select the absolute best one, just like a lead engineer would out in the field. Finally, Step 3 requires you to identify the exact tasks required to complete the build. Achieving these final design outcomes triggers a massive barrage of performance indicators. You are being validated across multiple axes simultaneously. Meeting functional requirements, selecting the winning proposal, and identifying required tasks triggers validation checks that ensure everything from technical accuracy to practical feasibility. This heavy concentration of metrics proves that this final stage is incredibly rigorous. It's the ultimate validation that you haven't just memorized facts, but that you can engineer a real, functional solution that passes multiple real-world criteria checks. And remember from our initial overview, the ultimate culmination of mastering all these indicators is to pull off a flawless demonstration of your edge storage system. As the syllabus specifically mandates, this demonstration has to be executed using an open-source tool. Why open source? Well, by mandating these tools, the curriculum ensures that anyone, regardless of their enterprise budget, can get highly practical, hands-on experience deploying their theoretical designs into the real world. It makes this advanced engineering education incredibly accessible to everyone. So, now that you have the blueprints for how this incredible technology is taught and validated, the curriculum leaves the learner with one final, really vital task. Under the self-learning topics, it asks, what are the current trends in edge storage systems available in the market? If you're looking to hire an edge engineer, or maybe become one yourself, this is the exact gauntlet you need to run. I'll leave you with this assigned self-learning question to investigate exactly where this exciting market is heading next. Keep questioning the infrastructure around you, because once you truly understand the foundation, the only place to look is the future. Thanks for joining me for this explainer today.